I will create a new file and give you a couple of tricks that how we are doing all these analysis. So first, you need to install these packages, but after you install, you need to load them into your environment. So for example, what I'm going to do, I'm going to write this library, DSig2, for example, DSig2. So see, this is loaded now. And another one, a jar, for example, library, edge R. So whatever libraries you want to use in the future, you need to load them using this command. And our color brewer. So I'm going to create a heat map, and I will use the colors from this package. That's why I'm installing that, loading them, loading it. Excuse me. And gplots. I'm going to do that too. You can either use the quotes or you don't need to use the library. Okay, everything is loaded. So when you load these things, so there's another thing here that you can write your own functions in the future that you can, after you learn R enough, you can write the functions like this. For example, I have this run DSig function here. And what it is doing is just running DSig with my data that I prepare, with the columns I choose in my data set and conditions I define with these parameters. So if you create this kind of function in the future, or you can use the functions we created for you, these are like, generic functions, you can load these functions, or you can download this into your own computer, put into your working space, and you can just load this into your environment. So it's on the web now, this whole file. So you can always use this the source. Like, where is that? Bootcamp. So you need to use the source function to load anything on the web. So the other people sometimes are going to do the same thing. So you want to use their functions that you like, you can do this. If the source is in your own folder, you can just remove this path, like the URL, and if it's in the same folder, you can just use these functions that are, like you can source it from there. So this is a good function. Let me do that. Source in the parentheses, and then I'll load. See, when I source this, so this will come to my environment. See all the functions here, like all-to-all scatter plot function, get normalized matrix function that you can change the method. Or we're going to find significant genes using run DSig and overlay that significant genes using this function on our ggplot. Or you can run heat map, or you can run volcano plot function, or plot PCA function, or run PCA function. So these functions are going to help you do things faster, but you can always go and learn how we are doing those things by looking this file. See, the code is here, plot PCA or run PCA. We are using, for example, PR-comp function and sending some more like parameters and data into that function like this. So when you start feeling yourself more comfortable in the future, you can go in and look what we are doing here. Everything is open for, and then you can start adapting them according to your needs or change them if you want to add more functionalities to these functions. So for example, this heatmap.to is a function. It has many, many different parameters. We used like a couple of them on here, maybe, I don't know, 10, 9, 10 different parameters. But what you can do for any function that you like to use and adapt and change, you can always come to your RStudio, use question mark and see heatmap to see. you can see this function, and these are the parameters you can use. Many parameters that you can define, and many more actually. So these are the explanations of the parameters. You can read and adapt that heat map according to your needs. So these are helping you a lot when you're writing your paper and adapting plots you created or heat maps someone's created for you. You can just get the data and then play with that. So what we're going to do today is let's do stuff in the bootcamp here. So there's this upload your file using this one. There's an upload function there too, that if you want to upload file to the cluster, you can use here, upload. It's gonna upload to your home directory or any directory. You can browse and upload the files there. And that helps you to analyze your own data by changing. But now today, what I'm gonna do is maybe so you just get this data. Maybe we can do that. But what I'm gonna do, I'm just gonna download this data into my own environment. You can either click here to download, or you can click download and upload here, but I'm just gonna download it. It's now in my downloads directory. Oops, I clicked. What did I do? Oops. Okay, it's just opened it because it's a TSV file. But let me go back. Okay, so either you can upload that directory if you're working on the cluster, just upload that directory, and it's going to be in your home, or if you browse and upload any other directory. So you have to write the right place to open that file. So now I'm going to show you how to open a file. So in this case, this is a tab separated file, but and it's an RSAM file. What I'm going to do, I'm going to go step by step here. I want you to understand how we are doing these kind of operations. In RStudio, there are a couple of things, a couple of functionalities that you can load a file. One is here, import dataset. RStudio has this function. What it's doing, actually, it's helping you to load that file into your environment using the command. It's creating actually that read command. So let's do that. Like, you can read from Excel file, you can read from a text file, but I'm just going to do this text file just to show you it's in my downloads. And the name was data. I already have data somewhere else, but let me do this for now. But I'm just going to do it like this. So it's telling you encoding is automatic. Sometimes, there are different type of encoding. It's not important. The heading. So we have a heading here. So the first line is heading. And this is a top separated file that we created like this. So if I don't change anything here, so when I import like this, see, read, delimiter, header false, it's just edit like such things. See, if I don't do all those changes there, my header is in the first line. And V1, V2, V3, it just gave the header by itself. So, but I don't want that. What I want to do is I want to update this functionality. Like, either you can use the command from here. I like doing myself, like, or let me change the name of that file. It's in my downloads. I'm just gonna change this to my data for now. I don't like that dot in the file name because it's changing the file name. So as you can tell, I'm just gonna close this for now, and I'll show you that again. Where is that? Import. So now it's my downloads. The name was my data. So, and now I'm gonna put the header here. Yes. So now see, it shows like a little bit darker, like, bold, and we know that it's header. And also I want to put the gene names as a row name. See, row names. When you do this, you're going to see it's going to add a couple of good functionalities to access the data in this matrix. So I'm just going to use the first column, or you can use a number to select any other column in this data set. But I'm just going to use the first column, and the separator is top. You can change the white space, comma, or semicolon. So this is one way to do that. But when I do this, and I have this, my data, and I want to put that here too. See, I use this functionality. It ran, RStudio ran it here, and I can actually see the command and copy into my records that in the future I want to use this. Because maybe in the future you're going to change the name of the file, and then you're going to use the same script that you created. And row names is in one. And there were before, header was false. Either the default version of this parameter is true. So you don't need to write if the default is true, but you can still write header is true just to remind you, like this. Okay, my data. And when I use that, see, there is this view function. So when I use view function myself, like this, view my data, see, it opens this table, and these are row names are here. Again, it's bold, and my header is here. So these are cool functionalities. And also another thing that you can learn, this is head my data. I usually use this just to check if everything looks fine. And see, head is going to write first 6 lines in your data structure. And in this file, what I have is like the gene names and transcript names here, and my quantifications for each sample that I use. So these are already prepared for you. And then you can use this while drawing these files. But when you run, for example, Dolphin Next, or when you in week 3, week 4. So when you do those things, you're going to have this RSum table. And using that RSum table, you can follow the instructions we are doing today. So when you read the file and when ahead, you see everything is right, and we like what we see and what we want to do. For example, there are a couple of things I want to show you why we read the file like this and put the row names here. So my data is a matrix, and it has 2 parts in this data structure. And the first part is the rows, and the last part about the columns. So for example, if I only want to have these 2 columns, for example, you can do like this: C, experimental replica 1. So this C, experimental, maybe I can put this into another variable, my calls, variable, my columns. So I just put these 2 columns from my data. See, my calls has these 2 columns. It's a vector. So you can create the vectors like you learned in the swirl tutorial for strings too, like this, and then put into here. So when I use this variable here, and if I do head to print first 6 lines, see, it just only brought me these 2 columns. That's cool. The other thing you can do here is you can create another vector for a couple of genes that you want to see their quantifications in this table. So, but we're going to use the first part this time. So for example, you can create another my genes vector. And in that vector, I'm going to put like this sp2 gene. Maybe I could write faster. sp2 and src. And maybe FGF21. So we are into this gene because we know that this is upregulated. So these are my genes. I'm just going to show you. I put this as a vector. I see them like SP2, SRCFG21. So even that, you know, when I use like, because I know this is a vector. So when I do my genes 3, see the third element in my vector is FGF21, because I know that I put this is the third one. And when I write like this, you can actually get the gene name. Here, in the first section, I told you that this is the rows. So when I put my genes here and head, yeah, you don't need head because there are only 3 elements here. See, you can get a subset of your matrix easily by doing these kind of operations. But you don't need to put this my genes here. You can also do like this too. I just put this into a variable, but I could have done, I could put this into here too. My data, this. And for example, if I, and after comma, if I keep this empty, if I don't choose any columns, it's gonna give me only for these 3 genes, all columns. See, all columns came. So if I want to bring the columns that I want, I can do like that too. So, you know, when you start using this, you're gonna get familiar of this variable usage, and also without using, if you're not gonna change this a lot in the future, you don't need to do. But, you know, most of the time I put like a group of genes that I'm always curious about looking, I put them into these kind of lists and create multiple lists. And using those multiple lists, I overlay those gene names on top of my plots, for example. So these kind of variables will help you a lot in the future. Just think about how you can actually utilize. So in this tutorial, what we're gonna do, we're gonna just choose the columns. I don't want transcript column here. I just want to use the rest. So how you can do this, you can put your columns, like all these columns I want to use. See, I can actually put into different lines, like after comma, you can put them all into different lines like this if you want to be more organized or see them separately like this, but make sure you have the column here, and then you can create these columns. And see, columns is again a vector. It includes all of them. If I do, for example, columns, it's a vector. So third one will be this experimental replicate 3. So that's cool. We can access the columns. By the way, you can stop me and ask questions if you have any. So you can ask me how I can do this and how I can do that. It's not going to slow us too much down. I can answer. So now I want to prepare my data using my data here with these columns I selected. See, same thing I'm doing like I did here. And I create a data frame. I'm going to tell you why. But this is another functionality, gives you some more flexibility, more functionality to my data structure. So here, for example, I can do such things like when I use dollar symbol, see, I can get the columns like this. If we need something like, for example, this column in my data structure, I put it here, and I want to get my genes quantifications, for example, if I want to use this, sorry, why didn't I want, because, nope, let me see, it's not working how I want. Let's see what I have here. They're also upgrading these things and changing the functionalities. Sometimes you do something, it works. That's why I was talking about, yeah, these are here. But then the names are not here. Sorry. The naming, I lost the naming when I just get one column. See, it doesn't know which gene this is. So, but if you, when you just reach one column like this, it's not gonna work. Sorry. But there are other functionalities that that I created this data frame because the functions I'm going to use now here, ggplot, requires a data frame. That's why I'm showing to create this data frame, because inside of data frame, it's using the dollar symbol in this function. Okay, so what I'm going to do now, I created my data frame for this data, and I put this data variable. Now it's here, and when I show this head data, you're going to see that transcript column is not here anymore. See, and there's another function like summary, for example, that will tell you more information about this data set. See, summary is going to give you the minimum count, first quartile, median, mean of this column, max, and third quartile. And these are all numeric values. So that's also good. And this summary function will tell you sometimes, because you're doing this and you're loading a file, because there is one code somewhere in the column, anywhere in the column might change that file, that column definition. When it sees the column here in that column, so when it sees this codes in that column, so what it is doing is it thinks that it is string value or text, and when you do summary, if it is text, it doesn't think that this is a numerical value, and when you draw the plots, you get wrong plots. So you have to be really, really careful here. That's why the summary will help you a lot to see that this is a numerical value. Sometimes, if it is not numerical value, you need to use other functions like as numeric, that we are always doing, like, you know, in this, maybe you can see the conversion here, integer to as integer, for example. We are converting them to integer values, or if we are going to use the matrix, we are using as matrix. So sometimes, like for example, here we are converting the factor, because the volcano plot requires a factor. So, or DE-seq2, like DE-seq2, or as this requires distance calculations. So that's why you have to, in this case, for example, PCA requires factor. So R is like kind of different than other languages. If you know Perl, if you know C or other languages, sometimes it's very hard to adapt R, because, you know, you have to make sure that what you're doing is right. And there are some problems like this that you have to actually understand the data type. When you open, it's not, sometimes it's not numeric, and then you're using these kind of functionalities to convert and test and check if they are right or not. So this, if this is not numeric, before you start drawing plots, you have to do it. Otherwise, your plot will be totally wrong. You might think it's right. You publish that. Sometimes I saw those kind of things, that the plots are wrong. So let's go back to Bootcamp. Okay. Here, now I'm going to define my experiment conditions and control conditions and put them into new variables. That is going to be in my R, X, and control. These are also variables. X, see, 3 vectors. So I use again C command, C function, to create my vector with these strings. So, and then I will, where was it? Okay, and then what I will calculate roll means of expect and like the controls. You can do something like this. So that's a cool functionality, that just roll means this can actually do that. Like this, roll means. You can even do this, means X, experiment means, and control means. You can do like that too. It works like this, but you can also do like this too. So all rows and only this columns and only this control columns. So when you do this, it's going to calculate the means of the rows. And what you're going to get is a vector. See, means X is going to be vector. Okay. But in this case, raw means carry all these gene names too. So if I want to see mean X, it is going to get the mean of only the experiments, okay? And this is going to get the mean of only the controls because I want to create a scatter plot using those means here. So, but if I want to do like FGF21 to see what is the mean for experiments, see 499, and you can do like that, and mean control, this was like this, mean control, means control. Oops, I didn't run that. Okay, so when you run, you need to run it. See, means control is 135 for FGF21. Again, you want to check the genes that we checked before, my genes. You can always use that too. Like you can put the my genes here. See, 3 of them are here. It's pretty cool. But now we have this too, mean X and means control. So there is a command to put them together into a single variable that I know that these are sorted, like because I find the row means using this functionality. It didn't change the order of the genes. So when you do cbind, it's just a column bind. And I know that the size, by the way, you can use this gene to see the size of your data, for example. I have 30,000 lines in this data structure, in this matrix, and 6 columns. So you can actually understand what you have there. So in this case, when I cbind these two, and I put them into average all, and what happened is, because this has a vector now, only includes row means, and this is another vector, and only includes row means. So when I show you that had average all, see, I have 2 columns now because I merge 2 different vectors. So those are one-dimensional vectors. And then when I merge, I get 2. So when I use dim command on this, average all, see, same number of lines, I know, and only 2 columns now, and I have the mean expressions. So if you want to change the names of these columns, because these names will be in my plot when I do my plot, that maybe I can. And so if you want to change them, you can just use this call names function. So this average all call names function, and then you can put this C treat. And now I change the call names. And when I do this, head, see, treat and control, treatment and control. So there is something that you can do very fast just to check how it is looking. Plot average all. And it's gonna plot, like, you know, you can very fast look at your data. But this is not looking like this. This is a pretty version, but at least the data distribution is not the same. What do you think is that? Is there anybody who can tell me what's the reason that I don't see data is like distributed like a nice RNA-seq data when you compare treatment versus control? Anybody can tell?
Scale.
Why the distribution is not the same?
The units, the scale on the X and Y axis.
Not the scale, but kind of scale, but there is something that about this quantification. So see, same counts, but there's something different intrinsically in this data. Okay, I'm gonna tell. So because the data is mostly skewed toward the 0 here, and when you don't draw them, these plots with log scale, log scale, yeah, that's why I said it's about the scale, but in log, you need to use the log algorithm here to convert the data, transfer the data like this. Otherwise, it's not gonna look like that. So when I use log 10 or log, natural log or log 2, it's gonna be like that. So this is the same. But I don't like using this. Yeah, you're close. I wanted to hear log. But this is a log scale. So sometimes you want to use log 10. So it's the same, but this is log 10 scale now here. So 2 means hundreds. They are around the genes. Gene counts are around here are hundreds. So this is going to be like a million here. So you can actually draw this. But I like ggplot, and I want you to learn ggplot here. So first, again, to make this, you need to convert to data frame, learn data frame here. And I put this name g dot. And now, to be able to create a ggplot, I'm going to do step by step here. ggplot is when you just do this, it's going to be empty. It's not going to do anything. But you need to add the layers to your ggplot. The first layer, for example, my data. Okay, if I just do this geom point. So I'm going to use the geom point. You can do geom bar or some other functionalities ggplot has. You can create bar plots or other stuff. So I'm just going to do this. G dot, sorry, I told them many different things. I did this ggplot plus geom point, and I need to select my columns here. Okay, I'm just going to put the columns, and the X will be treatment, Y will be control. I prepared that before, and I'm using now. Sorry, library ggplot. Okay, so I loaded my library. Didn't I load before? Sorry, ggplot here. Okay, see, it's not in log scale. Same thing you saw before with plot function that I used here, but this has other functionalities you can add to change the scale here. You can put the plus here, and I will add the scale. For example, for scale here, scale X. Sometimes you just want to scale only X. You can just add this. See, this is scaled, but the other is not. That's why you see like this. But when I do plus y-axis 2, scale log 10, then you're going to see better looking plots. Good. So this is what, but I still don't see transparency in these dots to see where they are accumulated mostly in my plot, but you can use other things. There are, again, many, when you check geom point, you can see lots of other parameters you can use and many different examples here. And you can also check ggplot in the web too. It's going to help you a lot. And I'm just going to add, for example, the color black and alpha transparency and the size 3 to get this exactly the same plot like in here. I'm going to put this here. And done. Okay, so this is how I ignore the warnings for now. No, it's not important because there are some 0 values here that when you get the log of 0 values, you get infinite for that access. That's why you get the warning. But usually when we do these kind of things, we remove 0 values and plot without zeros. But again, in one axis, even in both axes, if it's 0, it's coming here, then you get infinite calculations. But if it's in one axis, you don't want to remove that because you want to see even it's 0 in control, but there is a value in treatment that you want to understand what they are, and maybe it's upregulated in the treatment. So we are going to find those things using the seq analysis. I think today we are done. We're going to, any questions? Okay. So maybe the last thing, how you can actually remove these 0 counts and how you decide. Maybe you can read this filtering option here. And here, let me do that just to show how it is looking. See, histogram is going to show you the bimodal distribution. What I did was I just get the sums of my data, like all columns, and this is going to be your vector. See, same thing like head, maybe some D, tell you easier or better. See, all my genes, and these are sums, row sums. See, row sum command is doing that. So when you do the histogram with the log 10, and I put the breaks 100, and in each break, this histogram is showing the number of genes in that break. So for example, in this case, many of them are around 0, and because this is log scale, there are minus, and there are some values in between 0 to 1, 2, and you get these kind of numbers. So when you do this, what we do, there's a bimodal distribution here. Even some values up to like 1 here, 1 means 10, read count 10. So we usually remove those to get a better distribution, because those number of genes here, there are maybe 20,000 genes total when you look at here, are going to harm your p-value calculations if you don't remove them. So imagine when you do the correction on your p-values that we're going to talk about later. So imagine using 30,000 genes in your test versus 13,000 genes or 12,000 genes. There are like many genes, 18,000 genes are 0. So you want to remove them. And then your adjusted p-value calculations will be more correct. And we are going to talk about what it is in the next session. Okay, it's 12. Thank you very much. We had lots of problems today. I'm sorry about that, the systems are always changing, that we cannot control. But you need to learn this, like, because in the future, you're going to see this is going to happen to you many, many times, because the people at the background, they are not thinking you too much. They are thinking their own system and when they're installing something, they are like, uninstalling some other things that will make you put you into trouble. So, but the thing is, that's why actually this is one of the main reasons that we are using Dolphin Next, because when you use Dolphin Next, we just encapsulate all these packages and all this software with exactly the same version into a container, Singularity container or Docker container. When we use this, we never had problems. So this is telling you why it is pain to do all these things yourself, why it is much easier when you use a tool and all Singularity or Docker approach that will actually a good investment for your future to reproduce what you did before. Thank you very much to join today. Please let us know if you have any questions.
For these exercises, is it better to use the cluster or our own machine, the RStudio on our own machine?
So you should be able to run them anywhere. But the problem about the cluster, if you have a trouble while installing those things to your cluster account, because everybody's account is different, you install this and that, sometimes it doesn't allow you to install this package because something else prevent doing that installation. So if you have a trouble installing those things in the cluster, let us know. We can try to help solve those problems. If we cannot help, you can do this with cluster people, but I suggest you to utilize cluster resources because it's free. And when you make it work there, when you adapt yourself to that environment, then in the future, you're just going to start run there. Maybe some runs will take hours. You can shut your computer down and then when you get the results, you can go next day. So that's why I suggest you to learn how to solve the problems in the cluster. But again, if you can do this in your own computer, in many cases, I do many things on my own computer, by the way. I solve many problems. If the data is small, I do it on my computer. I suggest utilizing both resources.
By the way, Alper, just to give you a comment on the last thing you just said, it's usually easier to do bulk RNA analysis on the computer because we have a few number of samples.
Yes.
But when it comes to single cell analysis, mostly it doesn't work because single cell requires much more memory. Considering the fact that you have thousands of cells as opposed to just a few number of bulk samples, it actually requires much more memory. So when I usually do, and Alper does, is that when we do bulk analysis, we usually use our own computers. But when we do single cell, we usually switch to RStudio server. That's much more convenient because you usually hit the bottleneck of your memory when you do single cell on your own computer. Even data management of single cell data is extremely hard in your regular local computers.
Because sometimes you don't want to even download that huge single cell file, UMI file, into your computer because they take gigabytes.
We usually allocate the maximum amount of memory in cluster as well, because even sometimes 50 gigabytes of memory is not enough for a single cell. You have to use the entire 400 gigabytes just to manage the data, sometimes there are different kind of packages to do single cell analysis that we're going to see in the last week. Sometimes you want to switch packages, and even that requires a lot of memory. So interactive jobs will be much more helpful when you do single cell.
But to access the RStudio server on the cluster, do we need to access it through the VPN?
Yes, yeah, I realized that they changed it. So yes, so you need VPN to access there.
Okay.
If you don't have VPN, just write.
Yeah, I've never used VPN, so I'll have to first install that, and then use the RStudio on the cluster.
You can talk, yeah, exactly. So there's like Sonic or Open Pulse Secure, something like that. So just ask help desk or HPC admins how to install it. So it's just a software, and they're sending you this, or they're sending a link. You're clicking that link, and then when you install, your UMass like definitions will be in the software. You're just going to log in with your email, username, and password. Not cluster, email, username, and password.
And then the D browser download, I can do that after I get VPN access?
By the way, don't download the D browser to the cluster, because it has to be in your computer, because we already have it, D browser umassmed.edu in the cluster. So you don't want to do that in the cluster, and it should be in your local host. That's why try to do it there. And also it's much faster there in your local machine. So when it's on the cluster or in the browser umassmed.edu, it's slower. But still, if you need access, you can do it. You can use that dbrowser umassmed.edu version. But if you install it into your own computer without network, you can use it too.
Yeah, I had some errors. I think the compilation errors, or
yeah, I will actually look at those errors, because some other people also have it. I don't have it. I don't know why. Everybody's machine is different and installations are different. And again, like this is huge pain working on R sometimes, especially when they have a new version of R. Nobody's adapting the old version to the new version, so everybody has to go and check the dependencies and fix their own dependencies. Some dependencies are not fixed there. Even I fixed the browser, I wrote the browser, but some other dependencies that they didn't like adapted to the new R version. It's just you have to manually install some of the stuff. Yeah, but when you have a problem, if you share me your problems, then maybe we can do another call like this that we can fix online. Or next week I will start going to the school, so you can drop by and we can install there too. Okay.
Okay, thank you. Maybe I'll contact you later because I had those issues. So
Okay.
I'll need help with the manual installation.
Good. Okay. Okay, guys. Nice to see you. Hope to see you next week. Bye.